Okay, welcome back, students. Let's go over 8.5. Okay, complex numbers, polar equations and graphs. Okay, once again, rectangular to polar coordinates. Okay, we talked about trig notation before. This is basically the same thing. Okay, except on a real versus imaginary graph, we're just going to use a real graph, but you know, it's the same point in space. It's just we're going to use angles and radius, okay, to get the location in space of that point, okay, on a real axis, a Cartesian coordinate axis, and it's not going to go to imaginary this time. Okay, so let's look at how we would plot the points. Okay, the rectangular coordinates x, y go to polar coordinates r theta. Okay, so xy goes to r theta. Plot the point. So I have r is 4 and theta is 135. So basically the same thing that we've been doing before. Okay, we're going to go out 4, 1, 2, 3, 4, and then we're going to go over 135 degrees. And we're going to draw a vector. Okay, or we just plot the point. In this case, it's not a vector. Okay, so I can get rid of this guy here. Okay, and so this is just that point in space of 4, 135. Okay, what about negative 5 pi over 6? Well, pi over 6 is 30 degrees. Okay, so that's going to be here. But instead of going positive 5, 30 degrees, we're going to go negative. So we're going to go backwards. Negative 5. So negative 5, 30 degrees is the same as positive, or sorry, negative 5, 30 degrees is the same as positive 5, 210 degrees. So let's 1, 2, 3, 4, 5. Okay, so there's that point. Okay, and then 6, negative pi over 2. Well, negative pi over 2 is going to be negative 90 degrees. So it's really at that 270 degree mark. And we're going to go down 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, it's right there. Okay, so that one's there. This one's here. And this one looks like it's there. 1, 2, 3, 4. Yeah. Okay, and we could label these if we wanted to as well. So this would be 4, 135 degrees. This would be negative 5. Oops. Negative 5 and pi over 6. Okay, and then this down here would be 6 and negative pi over 2. Okay. Okay, let's take this first point here, this 4, 135, and let's see what we could, where that would be in rectangular coordinates, just our regular xy coordinates. So we're going to say that r is equal to 4 and theta is equal to 135 degrees, very similar to what we were doing before with the complex numbers. We're going to say x is equal to r cosine theta and y is equal to r sine theta. And so this is going to be 4 times the cosine of 135. Okay, that's x. And y is equal to 4 times the sine of 135 degrees. Okay, that's good. Okay, and so, well, this is 4 cosine of 135. That's going to be, remember, this is a 45-degree reference angle. Okay, and so it's going to be negative radical 2 over 2. And for the x value, and the y value is going to be, the sine of 135 is going to be positive radical 2 over 2. The 2's are going to cancel. The 2's are going to cancel. And I'll get a 2, negative 2 radical 2 for the x value. And y is going to be equal to 2 radical 2. And so my point in rectangular coordinates is negative 2 radical 2, comma 2 radical 2. Okay. It says determine two other pairs of polar coordinates for this point. How could I write this point 4, 135 differently? Okay, so we have this 135 degrees and we're out 4. Okay, I'll just rewrite the point 4, 135. Okay, any other way to write that to get the same location? Well, we could go out 4 and just go negative. Okay, so what would the negative direction be? 4 and then negative. So what I would do is I would take negative 360 and add 135 to it. Okay, or just subtract 135 from 360. Let's do that. 135 minus 360. I'm going backwards. And so this is negative 225. Okay. So for negative 225 degrees, we could do that. The other thing that I could do is I could, instead of going in the positive direction for, I could say, well, what if I had gone negative? Where would I have had, what angle would I have to go to so that I would be going negative 4? So I would have to be going this angle here, okay, either positive or negative. And this reference angle is 45 degrees, remember? Okay, so I would have to go negative 45 degrees. So if I did negative 4, negative 45 degrees, that's another angle that I could go through. Okay, I go negative 45 degrees. Okay, but instead of going positive direction, I would go negative direction, and that would get me to my original point. Okay, convert each equation between rectangular and polar coordinates. Okay, so I want to make this, turn this into a polar equation where we just have r and theta. Okay, we're going to make our x and y's go to r and thetas. And so, well, what was y? Well, y was equal to r sine theta. So I'm gonna replace this as r sine theta, and this is equal to 2. And what was x? X was r cosine theta minus 4. Okay. So I'm gonna now solve for r. Okay, and like we solved for y here, I'm gonna solve for r. So I'm going to subtract 2r cosine theta from both sides. 2r cosine theta. Okay, and I get r sine theta minus 2r cosine theta is equal to negative 4. I'm going to factor out an r. I get sine theta minus 2 cosine theta is equal to negative 4. And then I'm going to divide by that sine theta minus 2 cosine theta. Okay, and I'm going to end up with r on one side, which is what I want, equals negative 4 over sine theta minus 2 cosine theta. And that is my line in polar form. Okay, so this is in polar form. Call it a polar equation. Okay, that's the line y equals 2x minus 4 in polar form. Okay, what about the next one here? X squared plus y squared equals 25. Well, what does x squared plus y squared equal? Well, that just equals r squared. R squared is equal to X squared. So this is just R squared is equal to 25. Okay, let's solve for R. Take the square root of both sides, plus or minus, we get R is equal to plus or minus 5. Okay, well, what is that going to make? That's all the points, excuse me, that's all the points that are either plus 5 or minus 5 from the center. Okay, that's actually a circle. I didn't draw that real well. Let me do it a little less sloppy. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Still a little sloppy, but that's okay. Okay, and so this is a circle of radius 5. Okay, so all the points, we don't care about the theta in this case because theta can be anything we want it to be. Okay, but it's just a circle of radius 5. It's all the points that could be positive or negative. Now, we don't need the plus or minus. We could just go r equals 5, and that's going to give me the same thing. That's just a circle of radius 5. Okay, and this thing up here was a line. Okay, this thing's a circle of radius 5. Okay, what about the next one here? This one is a trigonometric equation, polar equation, and we want to change it to rectangular. Okay, well, what is r in rectangular? Well, r is the square root of x squared plus y squared. That's what r is. Okay, what's 1 over 1 minus cosine theta? Okay. So I know that x is equal to r cosine theta. So what would cosine theta be? Wouldn't it be x over r? Right? Wouldn't that be cosine? So this would be x over r. Okay. Let's think about this for a second. Okay. Yeah, I like what I've done there. Let's look at the r real quick. Instead of turning it into an x squared, let's try to see what we can do with the r real quick. Okay, if I multiply both top and bottom here by r, I will get r is equal to r on the top. If I distribute this r, I get r minus x. Okay. Okay, that's a lot of r's. Let's see how else I want to do this. Okay. Actually, let's do it this way. Okay. Let's take and multiply both sides by, because this is gonna give me my r cosine theta, which is nice. Multiply both sides by 1 minus cosine theta. Okay, 1 minus cos theta. Okay, so now I'm going to distribute the r. So this is r minus r cosine theta, which is nice. That's going to give me my x value, and then so that's just going to give me 1. Okay. So this thing is x. So I'm going to get r, okay, minus x is equal to 1. Okay, so let's add x to both sides. And I get r is equal to x plus 1, but I need to deal with this r now. Okay, and that's going to be x squared plus y squared square root is equal to x plus 1. Okay, this can be nice. Because what I can do now is I can square both sides. And I get x squared plus y squared is equal to, squaring this out, is this going to be x plus 1 times x plus 1, which is x squared plus 2x plus 1. Okay, and I can subtract off the x squareds. And I get y squared is equal to 2x plus 1. Okay. If I solve for x, because it has a y squared here, if I solve for x, okay, I can subtract 1 from both sides. I get 2x is equal to y squared minus 1, and then divide by 2, and I get x is equal to 1/2 y squared. I can make this a common denominator, 1/2 y squared minus 1/2. And that's a parabola, okay? It's a parabola that opens to the right. Okay, it's gonna look like that, but it is a parabola. Okay, so we had a line, we had a circle, and we ended up having a parabola as well. Okay, very nice. Okay, how do we graph in polar equations? How do we graph one of these polar equations? How do we graph that in polar coordinates? Okay, well, we've seen certain equations produce certain graphs. Okay, for circles and spirals, if you have r is equal to a, like we saw before with r equals 5, that's just going to give you a circle of radius 5. If you have a sine theta, that's going to give you a circle above the x-axis. If it's a cosine theta, that's a circle that is going that's to the right of the y-axis. And then for r equals a theta, this is a spiral. Okay. The limacons, that's what they're how they're pronounced. Limacon, they're not limacons. Okay, is it on the O? I think it's on the I. There's a little accent there. Okay, the limacons, okay. Okay. R equals a plus or minus b sine theta. You don't have to have plus or minus. It's just saying if you have a plus or a minus, it's still a limacon. And or if you have r a plus b cosine theta. If a is less than b, then it has a loop, an inner loop. If a is equal to b, if they're the same number, then it's called a cardioid. It's basically a cardioid for cardiac, heart. Okay, it's a heart shape. Okay, a dimpled limacon is if a is greater than b, and a convex limacon is if a is greater than 2b. Oh. Okay, roses. Okay, and we call these petals. Okay, on the rose, these are petals. Okay, so or leaves. You can call them petals or leaves or however you want to call it. If you have r is equal to a sine n theta, then okay, then it will give you a certain number of petals or leaves, okay, on your rose. Okay, r is equal to a cosine n theta. If n is it has n leaves, if n is odd, so if it's odd, it has n leaves, or if it's if n is even, it has twice as many leaves. So for the r equals a cosine 2 theta here, it's even, so it has 4 leaves. Here, if a is an sorry, n is an odd number, and so this has 3 leaves. Okay, it has the same number of leaves if it's odd. 4 has 8, and 5 has 5. Okay, the lemon skates, okay, they're kind of like figure eights. Okay, and they have r squared equals a squared sine 2 theta. Gives me that type of a lemon skate, kind of going through the 45-degree angle there. And the lemon skate r squared equals a squared cosine 2 theta. That is a kind of a figure eight alongst the along the x-axis there. Okay. Okay, now when you try to graph these things, you're gonna want to choose nice values that you're gonna want to take the sines and cosines of. And what I generally do is I'm gonna limit myself to 0, pi over 2, basically 0, 90 degrees, you know, we could do 45, but I don't like the cosine of that because it has a radical in it. But basically 0, 90 degrees, 180, 270, and 360. That's what I'm going to limit myself to. The problem is when we go and we have this 3 in there, we kind of have to go backward and say, okay, what times 3 is going to give me my 90 degrees? Okay, but I really want to take the cosine of those nice numbers so that I don't have to do a whole lot of, you know, it give me nice values to work with. So what I do is I'm going to draw a little chart here, and I'm going to say, hey, here's theta, right? But then there's 3 theta, and then there's cosine 3 theta, and then there's 4 cosine 3 theta. So I'm kind of building this in stages. Okay, and I really want to ask myself, well, what do I want the 3 theta to be? What do I want this 3 theta to be so that when I take the cosine of that, it's a nice number? And the first thing I want was probably 0. I want 0 to go in there. So when I take the cosine of 0, I get 0. Okay, I'm sorry, I get 1. Cosine of 0 is 1. And then I get 4 times the cosine of 0, which is 1. So 4 times 1 is 4. So I get a nice number there. I get a nice 4. And so I have to kind of, to go back to theta, I have to divide by 3. Instead of multiply by 3, I have to divide by 3 because I'm kind of reverse engineering that one. I'm saying, okay, what times 3 gives me 0? And that's 0. Okay, what times 3 gives me 0? The next one I want to do is 90 degrees. Let's do 90 degrees there. Okay, however, again, I have to go backwards. If I want to go back to theta, I have to divide by 3. So that's going to be 30 degrees is what I start with. Then I multiply by 3 to get my 90 degrees because I'm going to take the cosine of 90, which is 0, and then 4 times 0 is 0. So that gives me a nice number. Okay, and I'm going to continue to do this. I'm going to continue to work with these nice values. Okay, I'll continue to, I'm going to go into the first quadrant, but that's okay because there's not a lot going on in the first quadrant in this graph here. Okay, so what's the next nice number? I'm going to say that these are the nice numbers that I'm going to work with. Okay, the next nice number that I want to work with is probably 180 degrees. Okay, now let's divide that by 3. That's going to be 60 degrees. And what's the cosine of 180? That's -1. And what's 4 times -1? 4. Boom. Or -4. Boom, that was easy. Okay, what about what's the next nice number that I want to use? How about 270 degrees? Okay, divide that by 3. I get 90 degrees. Okay, and then the cosine of 270 is 0, and so I get 0 again. Okay, and so then what's the next one? Well, that would be 360. Oops. Try to make a line here. 360 degrees, right? Divide that by 3. That's 120 degrees. And then what's the cosine of 360? Well, it's 1. We just kind of go back to the root. So this thing's just going to cycle. Every 120 degrees, this thing's going to cycle. It's going to go 4, 0, -4, and then 4. Okay, back to 4. So in 120 degrees, we're going to get a whole cycle. Now, what is this? What type of graph is this? Well, this is a rose, okay, and it's a 3-leaved rose. So it's going to look like this guy here. So there are 3 cycles there. Okay, I'm going to get a rose, a petal for every 120 degrees here. Okay, so let's see how this thing builds. At 0, when theta is 0, I'm at 4. Okay, when theta is 0, I'm at 4. Okay, so 1, 2, 3, 4. I'm right here. Okay, at 30 degrees, I'm at 0. Okay, I went back to 0. Okay, and so if we were to put in more values there, what you would see is it would look like this. Okay, it would curve into itself there. Okay, now what are we gonna do? Okay, now 30 degrees, we're back, we're at 0. So we started here. We started right here. Okay, and then maybe I'll draw some arrows here. Okay, arrows of motion. Okay, and then we start there and then we go to 0. Okay, now from 0, where are we gonna go? Well, now we're at 60 degrees. Okay, so where's 60 degrees? 60 degrees is right here. Okay, but at 60 degrees, I'm at -4, so I have to go -4. At 60 degrees, I'm at -4, so down 4. 1, 2, 3, 4, down 4. Oh, okay, so now what does my graph look like? Maybe I'll do the graph in black. I don't know. Okay. Now it's going to go down like this. Oh, okay. We get a nice little curve that curves down like that. Okay, so now what's going to happen? Now we're going to go to 90 degrees. Okay, so what's happening at 90 degrees? Well, we're back at 0. So at 90 degrees, which is right here, I should put that in red. Okay, 90 degrees, we're back at 0. So we've got to go back, we've got to get back to 0 somehow. Okay, so we're going to go back to 0. Okay. And so this kind of makes a nice curve here. Okay, it curves, and then it curves back, and then it curves up, and you might be able to see what the pattern is here next. But what happens next? We go to 120. We're going to go to 120, and we're going to be out at 4. Okay, so let's go to 120. But where is 120? 120 is right here, and we're out at 4. Okay, so we came in like this, in like this, in like this. Okay, showing the motion. Then we started going like this. And then we curve this way now. Okay, curve like that and show the direction that we're moving. Okay, now where are we going to go after 120? Yeah, we're going to go back to 0, because again, this thing is just going to, okay, every 30 degrees, it's going to follow the same pattern. So what's 30 degrees from 120? Well, it's 150. Okay, it's 150, and then we're back at 0. Okay, and then 180, where are we going to be after 0? We're going to be back at -4. Okay, so this will send us back to 0. Whoops, it's a little big. This will send us back to 0 at 150. We're going to be back to 0. Okay, for 150. And then at 180, 1 to 0, right? And then 180, 1, 2, 3, 4. Okay, at 180 degrees, we have to be at a -4. So that's the opposite direction. So we're gonna actually cycle like this. And look at that. That created my 3-leafed rows. As I continue to go around and around, it's going to continue to cycle over and over again, and it's going to produce this 3-leaf rows. Okay, let's try the next one here. Okay, I'll actually move this up a little bit in my notes. Oops. See if I can grab this whole thing here. Move that up. Okay. Nice. I got everything except the 180. Okay, cool. Hmm. 150, 3 times 150. What do I have here? 20, 150, 180. I lost it. lost a row here somewhere. That's a row. That's a row. That's a row. That's a row. And that's a row. There we go. Okay, and so 360 plus 90 is 450. 450 plus 90 is 540. Okay. Yeah. And so this is going to be 0 and -1. There we go. Okay, let's go on to the next one, which this one here, B, is actually going to be a lemon skate. Okay, because it's right above. Okay, so this should give us our figure 8. Okay, except it's going to be a sine. So it's actually this lemon skate. Okay. Okay, and A is equal to 3 in this case. Maybe I'll put that down here. A is equal to 3. So this is going to be a lemon skate, and it should have a radius of 3. Okay, but we'll see, because you know the sine can only be sine can only go from -1 to 1, right? So the biggest thing that this could multiply to is 3 squared. Okay, and so A is equal to 3. And if I were to solve this for R, if I took the square root of both sides here, I would get plus or minus 3 times the square root of sine 2 theta. And again, the largest number that sine 2 theta could be is 1. So the largest number that R could be is 3. So again, the largest radius here is going to be 3. Well, let's build this guy. Okay, I'm going to give myself a little bit more room than I did before. So we have we're going to do theta 2 theta. Okay, and then I'm going to do the sine of 2 theta. Okay, I'm gonna leave it as the square root. Okay, I'm gonna do the square root of the sine of 2 theta, because that's just gonna give me a value for R, not R squared. I want a value for R. Okay, sine 2 theta, and then 3 times the square root of sine 2 theta. Okay. Okay, so now I want nice numbers to go in the 2 theta, because I want to take the sine of that. So it's going to give me a nice number. So nice numbers for 2 theta. Okay, so 0, 90, 180, 270, 360. I could keep going if I want to. I'm going to need to, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I need 9 values here. Okay, 1, 2, 3, 4, 5. I already have 5. So 360, because what I want is I want to go all the way up to 2 pi, I think. We'll see. 360, because if I want to go all the way up to 720, I think. So this is going to be 450, just keep going up by 9s, 540, and then 7 times 9 is 630, and 8 times 9 is 720. Okay, so I think I want to just grab those values, because when I have them, right, when I have them, I'm going to go up to 360. Okay, so 0, half of 0, this is 45, this is 90, so now I'm going up by 45s, so this is going to be 135, 180, this is going to be 225, half of 540 is 270, half of 630 is 315. Okay, so now I'm going to take the sine of the values in the second column. So the sine of 0 is, well, 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is negative 1. The sine of 360 is 0. The sine of 450 is the sine of 450 is the same as 90, so that's 1. It just keeps cycling through. 540 is 0. 630 is negative 1. And 720 is 0. Okay. So now let's take the square root of these numbers. Okay. So the square root of 0 is 0. Okay. The square root of 1 is 1. The square root of 0 is 0. The square root of negative 1 is I. So it's an imaginary number, and it's not going to be able to be listed on our coordinate system that we have here. So it's basically not going to exist. Instead of putting I, what I'm going to do is just put, I'm just going to leave it blank, or I'll just say, I could say undefined, maybe. Okay. 0, sine of 0, square root of 0 is 0, square root of 1 is 1, square root of 0 is 0, square root of negative 1, again, is undefined. Okay, under real, because this is the real coordinate system, not the imaginary one. And then 0 is 0. So 3 times 0 is 0, or 3 times 1 is 3, 3 times 0 is 0, 3 times undefined is undefined. Okay, 3 times 0 is 0, 3 times 1 is 3, 3 times 0 is 0, undefined, and then 0. Okay, so let's see what happens here as we go around the circle, right? We're going to go around from 0 to 360. Okay, we're going to go around the circle. So at 0 degrees, we're at 0. Okay, that's easy. 0, we're at 0. Okay, at 45, we end up at 3. At 45 degrees, we end up at 3. Okay, at 90 degrees, we're at 0. So we're back at 0. So we're going to go out like this and then back. Okay. At 135 degrees, it's undefined, which means there's no value. Okay, at 180 degrees, we're back at 0. So we went back to 0. Okay, at 225 degrees, we're at 3. 225 degrees, we're at 3. Okay, so we went this direction now. Okay, we came in here. You want to follow the arrows here. Okay, we came in here now. Okay, and we're gonna go like so. Okay, and then at 270, we're back to 0. So 270, we're back to 0. Okay, and at 315, we're undefined, and at 360, we're back to 0. Okay, and so we get this pattern here, and that is the lemon skate that you basically have up here. Okay, radius, the largest radius here is 3. Okay, and it's along that 45-degree angle. That's kind of cool. Okay, that's 8.5, and I'll see you guys in the next video, the last one.